here you see the question, and in options there are two types. First, we have to tell whether G is even or odd, and in if you see B and D, then you see a limit. So our work will we will work separately. First, we check for A and C. So let us write the function G. We have to say about G. So we write the function G here. You see gy equals to sup means supremum, maximum value, not a local maximum, overall maximum, xy minus fx. So to say whether it is even or odd, we find g minus y, so g minus y will be sup x tends to real number, and at the place of y we write minus y, and here minus fx as you see here. Now at supremum value also is a maximum value, but not a local maximum. As it is a maximum value, so differentiation of this should be 0. So suppose this is hx, this is lx, this underlined thing. So at maximum value h dash x is 0. Similarly here will be l dash x will be 0, and from this you will get, if you differentiate this with respect to x, then you will get y minus f dash x equals to 0, and here you have minus y minus f dash x equals to 0. This gives us y equals to f dash x, and here you have minus y equals to f dash x. Now put this value in this, then you have gy equals to sup x belongs to R x f dash x minus fx, and here if you put minus y at the place of minus y f dash x, then you will get the same thing, that is x f dash x minus fx, and you see here will be sup x belongs to R, as you see here, and you see that these two, that is gy equals to g minus y. And one more thing is to note that we have not assumed fx to be even or odd. So fx may be even or odd, but our gy is an even function. So according to options, option A is correct, because in it you see g is even if f is even. Now so since A is correct, C will be wrong. Now B and D, in B and D you see a limit, so let us go for that limit. Here you see sup x belongs to R, xy minus fx is finite. I am writing the same thing again here. Sup means supremum, x belongs to R, xy minus fx is finite for all y belonging to R. This means that finite, here is sup, finite means x minus fx should not tend to infinity. because here is sup means maximum value, and here is finite. You know, if this tends to infinity, and you know infinity is not a finite number, so this should not tend to infinite as x tends to plus minus infinity. When x tends to plus minus infinity, in both cases this should not tend to infinity. Now suppose x tends to infinity, plus minus infinity, and in it xy minus fx, you see two terms. First one is xy and second is fx. Suppose x tends to plus minus infinity for certain values of y, xy tends to plus infinity. You see, because if you take x tends to plus infinity and y is positive, then this whole thing xy will tend to plus infinity. But according to our scheme, this thing should not tend to plus infinity. So we have three cases regarding minus fx. Second term is minus fx. Minus fx may tend to a finite value. Three cases. Minus fx may tend to minus infinity. Minus fx may tend to plus infinity. There may be three cases, possible cases. Now suppose minus fx tends to finite, then first one you see is infinity plus infinity and plus finite value is a finite value. Then this whole thing will be plus infinity, and you know this should not be plus infinity. So this case is not acceptable. Now see the third, this one. If you see the third one, minus fx tends to infinity and this xy is tending to infinity, both tending to plus infinity, so sum of these two will be plus infinity, and according to our scheme this should not be plus infinity, so we cannot take even the third. Now it remains only the second, this one, minus fx tend to minus infinity as x tends to plus minus infinity. And if you remove minus sign from both sides, then you have fx tends to infinity as x tends to plus minus infinity. Now if you consider, if you overlook, if you imagine various types of functions, then you will get only one function, only one such type of function, that is polynomial functions. And you have to take this polynomial function fx as I write here. A is a positive constant, and here the highest term will be x to the power 2n, means you have to take the highest term with even power, because in that case if you put x plus minus, if you put plus, then it will be plus, if you put minus even, then it will be plus. So you have to take plus, you have to take the power as an even number. And also you must see that here both this infinity minus infinity, infinity minus infinity may be a finite number, and so this whole thing, if you tend this whole thing to minus infinity, maybe minus infinity, then in that case this fx should increase with greater speed. Greater speed means here is x to the power 1, so you have to take the highest power, the term with highest power. Here the power will be greater than that of this power 1. I mean greater than 1 means 2. You cannot take 3 because 3 is an odd number, so you have to take 2, 4, 6 etc. So in general we can write this power as 2n, where n is equals to 1 or greater than 1, and maybe some other terms whose power will be less than this 2n. Now if you find this limit lt x tends to infinity fx by mod x, then obviously this will be plus infinity, because you can take x square out as a common, and x square can be written as mod x square, and mod x square by mod x, one mod x will be cancelled and here it remains one mod x, and if you tend that mod x to infinity, then obviously this whole thing will tend to plus infinity. So our second correct option is B, because in B you see this tends to plus infinity. So correct options are A and B. This question is over.